Hi, we are going to do kinematics second part where we are going to talk about equations of motion using integral method. Then very important concept, projectile motion. What is a projectile? What is the path of the projectile? What is the time taken, etc. Equations of motion. Basically, few things we have to decide, we have to discuss before deriving the equations of motion. Assume u is the initial velocity of the body which is moving, v is the final velocity, a is the acceleration produced, t is the time taken, and s is the displacement. So this is the basic thing. U, V, A, T and S, we are going to derive equations. Three equations of motion we are going to derive. Okay. Acceleration. What is acceleration? Basic definition. It is rate of change of velocity dv by dt. dv is equal to a into dt. You integrate the equation both the sides. Integral dv is equal to integral a into dt. Integration you do. Integration with the limit. This is velocity. So initial velocity to final velocity. This is time. Initial time is 0. Final time is t. 0 to t. Integral dv is what? V. U to v. A is constant, take it out. Integral dt is t, limit 0 to t. So basically, integral limit means upper limit minus lower limit. Upper limit is v minus lower limit is u is equal to a into upper limit minus lower limit. That is a into t minus 0. So we can write v is equal to u plus at. V is equal to u plus at. Correct? A into t minus 0. So v is equal to u plus at. This is first equation of motion. Second one, here there is no displacement. Initial velocity u, final velocity v, acceleration a, time t is related. Second equation of motion, s is equal to ut plus half at square. That equation we are going to derive. Also, velocity v is equal to rate of change of displacement ds by dt. ds is equal to v into dt. Cross multiply. ds is equal to, what is v? U plus at into dt. U plus at into dt. Integrate the equation. Integral ds is equal to integral ds is equal to integral u plus at into dt. Now you have two terms. Integral ds is 0 to s. So s 0 to s limit. This is two terms. Integral u dt one term plus integral at dt another term. U dt one term, at dt another term. Upper limit minus lower limit is equal to 0 to t limit. 0 to t limit. U constant, take it out. Integral dt is t. 0 to t. A constant, take it out. T dt. Integral of t dt is t square by 2. T square by 2. Limit 0 to t. So all the three cases here lower limit is 0. So that is 0. So s is equal to ut plus half a constant t square. Ut plus half a t square. Second equation of motion. Third equation, again, acceleration a is equal to rate of change of velocity, you know, dv by dt. Multiply and divide by ds. Multiply and divide by ds here. But ds by dt is nothing but velocity. So this ds by dt can write as v. So what will happen? A is equal to dv into ds by dt is v by ds. Cross multiply. A ds is equal to v dv. We have to integrate the equation. Integral limit 0 to s. Here velocity is a variable. When you say velocity is the variable, u versus v, limit u to v, limit u to v. Okay, now integrate. A constant, integral ds is s, 0 to s is equal to v dv. What is integration? V square by 2. V square by 2. Limit u to v. A into s minus 0. Upper limit minus lower limit is equal to v square by 2 minus u square by 2. So I can write v square minus u square, cross multiply 2as. V square is u square plus 2as. This is third equation of motion. Here time is not involved. Using this we can do problems. Correct, Amma? Very, very important concept. Equations of kinematics or equations of motion. Okay, wow. Fine. Equations of motion for a freely falling body. For a freely falling body, what are the equations first? V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. For a freely falling body, Sir, there is a difference. Body is projected. Body is dropped. When you drop a body, there is no initial velocity here. When you project like this, you are giving some velocity. But when you drop, there is no initial velocity here. So for a freely falling body, initial velocity is zero. This is first point. Second point, when the body is moving with an acceleration A, velocity changes with the time. So we are telling acceleration. But in the case of freely falling body, there is no acceleration at all, because this acceleration changes to acceleration due to gravity. That means A replaces G. G replaced A. That means A becomes G there. Here we have acceleration, but it is acceleration due to gravity because the body is freely falling. Okay. Substitute, therefore, first equation, V is equal to GT. Initial velocity 0, A replaced by G. Second equation, S is equal to U becomes 0, half GT square. V square is equal to U0, 2GS we can write. No, sir, for a height H only it is coming. You can put H. 2GH. Correct, Amma? These are the equations for a freely falling body. So equations of motion or equations of kinematics. Equations of a freely falling body. Based on this, we can do problems. Okay, wow. Next, projectile motion.